Year 6 and welcome to the first maths lesson of the last week of remote learning. Can I get a whoop whoop? It's Monday the 1st of March. We're going to look at types of graphs or charts today. And this week, in fact, over the first few days this week, that's what we're going to be focusing on. Sun's shining again. Oh yeah. We're going to focus today on line graphs. So we're going to read and interpret line graphs. That's going to take us over the next few lessons this week. Alright, so today's lesson we'll have a bit of a starter task. We're going to look at some different types of graphs and charts and look at line graphs in more detail. And then we'll focus on your assignment for today. So let's start with the starter task. Okay, quick one here. There are 5 parts of this graph covered up. So down the right hand side we've got the labels: title, X for x-axis, Y for y-axis, weight and month. See if you can work out which label is which. You pause the video now. I'm sure you found that one quite straightforward, even for a Monday morning. Okay, so we've got at the top we've got the title in this case being a graph showing puppy's weight change over time. Along the bottom we've got month. That was a bit of a giveaway, wasn't it? We've got weight in kilograms of the left hand side, and then we've got X and Y. Now X is across, literally X is across as in the shape of it, but it also goes across from left to right, and Y is the vertical axis. Really important to remember those when it comes to writing your own line graphs. So let's look in a bit more detail at the different features of different graphs and charts and where we might use them. So pictograms, something that I know that my maths group have looked at in Daily 5 already this year. Literally a picture. Pictograms using pictures or symbols to represent data. Discrete data, so data that has a start and a finish. So often there's a key where the symbol will show a certain number. So in this first one circle represents 2 children, therefore half a circle represents 1 child. Or you could change it, it depends on what the data is, but in the bottom example you've got 1 circle showing 4 children, therefore 1 child will be shown by a quarter of the circle. So the most important thing with a pictogram is to identify the value of the symbol. Because you see in those 2 examples, the symbol is worth different values. So therefore, you need to know what the symbol is worth in order to find out the information. So similarly to pictograms, bar charts can show discrete data, which we can describe as data that is counted and has no in-between value. Okay, so whether a specific number that is counted, we call that discrete data. So it's usually presented as a bar chart. Now, as we said, with a line graph we have a horizontal and vertical axis. In this case, the x-axis shows the type of pet, and the number of children is the y-axis. You can see how the data from the table, the frequency table, has been transferred to the bar chart. So just as with the line graph, the chart always has a title. It's important with a bar chart, that each bar is the same width. And just as with the line graphs, each axis, the y-axis and the x-axis, must have a label explaining what it shows. You can also have different types of bar charts, such as a grouped bar chart or a dual bar chart, it's sometimes called, where you can show 2 sets of data. Okay, so very similar to the first one, the axes, plural of axis is axes. The axes are labelled, there's a title, and in this case there's a key, a colour key, to show which bar is which. Line graphs is our focus for the next few lessons. Now, line graphs are more commonly used for continuous data. Okay, so when the data is continuing or showing changes over time. Right, so not just a counting exercise when there are measurements taken over time and that data is continuous. So we plot the data on a line graph in the same way as we would with coordinates, where you find the value on the x-axis and then align it with the y-axis. So if you look at the example here, you can see time going across the x-axis and the temperature on the y-axis. You can see here that the temperature has been taken at regular intervals and the time. And the line graph gets its name because these data plots are then joined with straight lines. Sometimes, for example in science, we might look at trends or patterns. Okay, so here's another example of a line graph. We've got the correct labels. We've got the title, hot dogs sold per day. We've got the x and the y-axis labeled. We've got day on the bottom, the x-axis, and the y-axis shows the number of hot dogs sold. Okay, so can you present the data in this line graph in the table? So can you work out what the values from this line graph should be in this table? Pause the video now and have a go. Okay, so here are the answers. We've got 10 on Monday. Now we can see that because we can look where Monday is. We highlight Monday, and we can go up in a straight line to where the point is plotted. What we can do then is go along in a straight line to the y-axis and see that the value is exactly 10. It's on the line. It's 10. These intervals are increasing in 10 each time. Similarly for Tuesday, we can go up and then across 30, as is Wednesday because it's level on the y-axis with the Tuesday value. Thursday, again we can go up vertically and then across. That's 50. And Friday, we can go across and see that it is 70. One of the most important things you can do when you have a question involving line graphs and you're asked to read the data from it, get your ruler, get your pencil, and you can annotate the graph. You can draw on it in the same way that I've done here to work out what the value should be. All right, really important. Okay, so I've had a little bit of information about line graphs and other types of graphs and charts. We're going to look at the assignment now. Right, we will be doing more work on line graphs and other data throughout the other videos, but we're going to look at today's assignment now. Okay, so this is what one of the tasks looks like. This is a set of 5 questions based on this line graph here. So if you work your way through those, first of all, that is the first task today. And if you look at the bottom there, you can see it. What was the mean screen time? So we're going to apply our work on the mean from last week as well. All right, so a little bit of a recap of last week's tasks. Then the first challenge for today is, can you come up with your own set of questions for this line graph? Okay, so there's a line graph provided in the challenge task. Can you come up with your own set of questions? See if you can come up with 5 questions of your own based on this line graph. And the second challenge, bit of a trickier one, this one. All right, takes a little bit more thinking, a bit more explanation time as well. So there's a graph provided here, this line graph, showing the distance travelled in kilometres over time. For the first part, can you describe what has happened, what occurs between 4 and 6 minutes and between 8 and 10 minutes? You can see that the line changes. Can you describe what has happened? Remember, it's distance travelled over time. And for the second part, can you estimate, try and work out, how far the distance travelled will be after 1 hour? Okay, so the graph goes up to 15 minutes. 14 minutes rather. Can you estimate how far the distance travel will be after 1 hour? I want you to justify that. I want you to give me an explanation that proves why that will be the case. Okay, that's it for today's maths. Remember, you can submit your work on Teams, or you can send it to the Year 6 email address. And do not forget, we're also still battling on TT Rockstars. We had a great day on Friday. I hope you enjoyed some of the pictures that were uploaded on the Facebook page. Have a look if you haven't seen them. But keep going with the battling, and we'll see where we can get by the end of this week. Bye for now.